Okay, that last video did get cut off a little bit, but when you add those two together, you end up with 115 degrees. So that was the total direction that Esco walked when you're talking your true bearings there when you add those two together. Okay, let's try one more. So here we have a problem where there is no diagram given. So it says a helicopter A observes two ships B and C. B is 23.8 kilometers from the helicopter, and C is 31.9. So if we think about this, here is A, the helicopter, it's up in the air. And then, like, here is ship B, and here is ship C. So from B, from the helicopter to B and the helicopter to C, those are your two distances. So B is 23.8 and C is 31.9. And it says the angle of view, BAC, so BAC is this angle right here, is, in my drawing, doesn't look like it, but it's 83.6 degrees. And it says, how far are the ships apart? So I'm looking, that distance from B to C is what I'm looking for. So I have a side angle side here. And so side angle side indicates I could do law of cosine. So this is the angle across from it. That's the angle I need to use. So then this is going to be over on the left-hand side. So I have x squared equals, and in no particular order, I have 23.8 squared plus 31.9 squared minus 2 times 23.8 times 31.9 times the cosine of 83.6. Okay, and if we do this part right here, I end up with x squared is equal to 1584.05 minus, and then if I multiply this right here, I have 1518.44 times the cosine of 83.6. And then I have to take the square root of both sides. So I'm going to take the square root of that whole entire thing. And when I type that into my calculator, I find x to be 37.6, 3 sig fig. And so 37.6 kilometers is the distance between the two boats.